This video is about problems 4 and 5 on the summer assignment 2014. Here are problems 4 and 5. You had to say whether or not those were true statements. They are in fact most definitely false, and that is very easy to prove with a counterexample. For example, for problem 4, an easy counterexample, that is a number that makes the statement false. If I do 1 plus 2 and cube that, that's the same as 3 cubed. 3 times 3 times 3 is 27. And that is not equal to 1 cubed plus 2 cubed. Since 1 cubed plus 2 cubed would be 1 plus 8, which is 9. 9 is not equal to 27. So this is very much a false statement. But the interesting question one should ask oneself is, well, what does this left-hand side look like? If it's not x cubed plus y cubed, what is it? Well, in fact, you learned this way back in Algebra 2. Let's take x plus y cubed, and we know that's got to be x plus y times x plus y, the product of three factors of x plus y. And we can multiply this out the long way. I can multiply the second two factors. You should be able to FOIL that out. Remember doing this, and you get that result. Then I can simply multiply out the long way x times everything in the second parentheses plus, and then take y and multiply everything in the second parentheses. I'll get a total of 6 terms when I do that, but in fact those 6 terms will simplify to give me a total of 4 terms: x cubed plus 3 x squared y plus 3x y squared plus y cubed. Hey presto, we are done. Now you could imagine that if I wanted x plus y all raised to the 5th or the 7th power, it would be very tedious to multiply everything out. So the next question is there a quicker way? And the answer is, you bet. You learned the binomial theorem, which is a way of taking a binomial. A binomial is the sum of two terms, such as x plus y, that constitutes a binomial. And what happens when I raise that to some power? So let me take an example, such as, let's take x plus y again, and let's pick a different power, suppose the power 5. What the binomial theorem tells me is that if it's the power 5, I'm going to have 6 terms. There's always one more. And my 6 terms are these. I start with x, and it goes to the 5th power because my original power was 5. Then I have some number which I don't know quite at this moment. It's a coefficient that multiplies this, x to the 4th y, and then another number that I'm going to think about in just a minute, and that multiplies x cubed y squared, plus the next mystery number, which is in fact called a coefficient, and that multiplies x squared y cubed. You may notice that the powers of x go down by 1 each time, the powers of y go up by 1 each time, and the exponents will always add to 5, which is because I was raising originally x plus y was raised to the 5th power. Alright, let's keep going with this coefficient x. The power of x goes down 1, the power of y goes up 1, until I get to y to the 5th. I could think of in front of it x to the 0. X to the 0 is 1. So if I wanted to put x to the 0 in there, it would just simply be 1. So there are my 1, 2, 3, 4, 5, 6 terms. All I've got left is to find the missing coefficients. What go in here? All right. Okay. If you cast your mind back to Algebra 1, you met, whoops, I want to use a red pen. You met Pascal's triangle. Pascal's triangle is a quick way of coming up with the mystery coefficients. Right? Pascal's triangle is constructed like this. You start with a 1, and then you write 2 1s underneath. You always start with a 1, then you look at the next 2 numbers in the row above, add them, and that's 2. We're out of numbers, I finish with a 1. Start with a 1, add the 2 numbers in the row above, I get 3. Add the next 2 numbers in the row above, I get 3. I'm out of numbers, I've got a 1. You're going to continue like that. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And actually I can finish here because I was trying to find the expansion of, what was it? X plus y to the 5th. What I do is I go to the line that begins with 1, 5 because I was doing the expansion of x plus y to the 5th. And I look at the numbers in the row of Pascal's triangle, and they are going to give me my coefficients. Here they are. How do they go? 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. When you did the binomial theorem, you may have actually done it a little more mathematically. The coefficients, if you actually are, this is 5, choose 0, 5C0. This is 5C1, 5, choose 1, your teacher may have said. This is 5, choose 2, etc. But Pascal's triangle does give us a nice and quick way of coming up with the coefficients, providing, of course, you know, you're not expanding something to the 17th term, because then you'd have a whole lot of rows of Pascal's triangles to come up with. Okay, so let's check my answer for x plus y cubed. It's a cube. Therefore, I want the row that begins with 1, 3. All right, those are going to be the coefficients of my expansion. How does the expansion go? You start with x cubed. Oh, my pen is giving me a lot of grief. Here we go. X cubed plus my mystery number. The x's go down and the y's go up. Here we go. X goes down, the y goes up. X goes down one more. X to the 0 is 1. The y goes up. We finish with y cubed. I look at my row in Pascal's triangle, and I write in my coefficients. Well, I don't really have to write in the 1. And there we are. That's the answer. We're almost done. That certainly takes care of problem 4. Problem 5 was different. It was x minus y all cubed. And you might think, oh my gosh, do I have to have another binomial theorem? How do I cope with this? Well, the answer is, it is really very simple. I recognize that x minus y can always be written as x plus negative y. So what I'm doing is I am expanding x plus negative y to the all cubed. So all I need to do is to write negative, oops, fix that. This was negative y. So wherever I had y, I'm going to write negative y. So we're going to do that. So let's take the expansion that I do know, x plus y all cubed. Okay, it is x cubed. Wherever I have y, I'm going to write a negative y. 3x, wherever I have the y, I write a negative y. Okay, can you see it comes from this line? I have simply taken wherever I had a y, I'm writing a negative y. Okay, let's just see what we get for a final answer from this. All right, we'll do that. It's going to be x cubed, and then when I simplify this, it is 3x squared y. Here, when I square negative y, it becomes positive, but I'm going to get a negative at the end. Again, I've got 1, 2, 3, 4 terms, and they alternate. Start with positive in this case, and then negative, positive, negative. And we are done. So that is binomial expansion. I'm just going to finish up by pointing out the difference between problem 4 and problem 19a. Problem 4, I had x plus y cubed, and problem 19a, I had x cubed plus y cubed. And I hope at this point you realize they are very different. The next video is going to look at 19a and b. What do I do with x cubed plus y cubed? And the answer to that is that we are going to factor them. And that is it for this video.